Right, I don't remember if this one's on, but very quickly, it's going to have a common term, okay, and we'll leave that negative 8 outside. 128, right, you can't square root that. What you can do is 64. 128 is 64 times 2. I bet you there's going to be a 2 left in everything on the other ones, okay, so 4's outside this one. Yep, this one's 16 times 2. Okay, again, square root the 16, leave the 2 behind, plus 6, and again, 50 will be 25 times 2. Okay, so you're going to remember, so 8's going to come out of here. Okay, square root of 64 is 8. With this negative 8, when you multiply, you're going to get negative 64. What's going to be left is the root 2. Right, this 16, you're going to square root it, you'll get 4. With this 4, you'll have 16. 4 times 4 is 16. Again, still a root 2 left. Again, when you square root this, that'll give you 5. When you square root that, 5 goes with this 6, it'll give you 30. 6 times 5 is 30. And basically, that is what you're doing, okay? Add all these together. So negative 64 root 2 plus 16. Not sure what that is. That's negative 40. I don't know. Is that negative 18 root 2? You kind of deal with that one, okay? How many root 2's do you have? You just combine basically the coefficients. Negative 64, add 16, plus 30, okay? Right. Rationalize denominators. This means multiply it by another root 3x, because root 3x times root 3x is 3x. Okay, that's why we do it. There's no square root sign now. But don't forget, to the bottom, got to do it to the top. Okay, so 12 times root 3x is just 12 root 3x. I can't do anything about that. Okay, that's all I can do. But look at this bit here, the 12 over the 3. Okay, so that'll give me 4. Okay, 12 divided by 3. That x is still there on the bottom. That root 3x is still there by itself. Remember, you can't cancel these x's. One's inside a square root and one's not. Okay, so leave it. That's the answer. Right. What should we do now? Here we go. Right, next one. Okay. I like these. These are good kind of staples. Hopefully you're okay with these. Okay. You need to isolate this root, a bit like the absolutes really. Absolute that by itself. Okay, sorry, 3x minus 1. Which means you have to take away 6 from both sides. Okay, take away 6 from both sides will leave you with 2. Okay, there you go. Okay, there we go. I've just taken away 6 from both sides. Now this is the important thing. You square both sides, because the square of the square root of 3x minus 1 is just the 3x minus 1. Don't forget to square this side. It's 4. We're squaring. We're not square rooting. We're squaring both sides. Okay, looks like I'm going to add a 1 to both sides. So 3x equals 5. So x must be 5 over 3. Okay, divide both sides by 3. There you go. That's the answer. Okay. Right, that's that one done. Let's keep on going. Looks like we're into the imaginary ones. Okay, the letter I. Okay, we're going to do this one. So this is just a straightforward multiplication. Just do a FOIL. This is a straightforward FOIL. 21 times 7. That's a great start. What's that? 147? 147. Okay. That's it. Okay. 21 times I is just 21i. Just like having an x there. Negative 3i times 7. Oh, that's going to go with that. Negative, was that negative 21i as well? Oh, that's good. Okay. Okay, I'll see those two are going to go. But finally, be careful. Negative 3 times 1, okay, is negative 3. And it's also got an I times an I, which is an I squared. Not an I, it's an I squared, remember. Some people can write an I there. That is negative 3I squared. But remember what I squared is? I squared is negative 1. This will change it to a positive 3. Okay. Now for this one, they cancel. So 147 plus 3. The answer must just be 150. So no i's left in that one. Okay, there you go. Right, now this one, when you're dividing, this kind of means like rationalize the denominator. Okay, to get rid of 2 minus 9 at the bottom, conjugates 2 plus 9i. Okay, 2 plus 9i. But also do the same to the top, 2 plus 9i. Okay, now the reason why we do this is this. Right, think of this as a FOIL. Now, 2 times 2 is 4. Now look at this. The outer will be positive 18i, the inner will be negative 18i. A bit like question 26, they will cancel. So really, all I'm doing is the first and the last. And the last, so negative 9i times positive 9i, right now is negative 81i squared. Remember, I squared is negative 1. This will change this to a positive 81, okay? Which, of course, is 85. Okay, positive 81. So, notice I've just been doing the denominator. That's 85. Right, the numerator is just the distributive law with the 9. 9 times 2 is 18. 9 times 9i is 81i. Now, I'm happy with that, folks. I mean, some instructors might say, well, if you have to write it like this, then it's just split into 2 bits. It's the 18 over the 85 is the kind of real number, and the 81 over 85, 81i, sorry, 81i over 85 is the non-real number, okay? So that's it. But I'm quite happy with this up here, folks. That's fine by me, okay? Okay, so I think we'll call that it for that one. I'll come with this page later, okay?